and everything in between. There were more than 300 scientists that spent 13 months on the ice, and for the most part frozen into the central Arctic Ocean. About 24 of them were from CU Boulder, so we celebrate all of them today too, supported by 14 grants from the National Science Foundation and a major project of the Department of Energy. They endured storms powerful enough to crack the ice underneath their research stations, forcing them to re-raise up towers, reposition buoys, and relink power cables. I can't even imagine, when we're doing things in a stable environment, it's challenging. Temperatures dropped to -40 degrees C, also -40 degrees F, enough to near instant frostbite if you're not extremely careful. And of course, polar bears would wander in through the research sites on the ice, sometimes with their cubs, and the scientists had to back off to the ship or other structures and wait for the bears to leave. Seals visited, and Arctic fox chewed through the data cables that were to be rewired. And being the electrical engineer, I'm glad to know that these were not power cables, so they were not electrocuted. And then came COVID, which forced the entire expedition to rearrange itself, with some people staying on the ship much longer than intended, to ensure people stayed healthy and data continued to be collected. And I think one of the questions we had at the kickoff is, how are people going to mentally stay stable throughout all this? So we'll have to find out from Matthew some of that, and if they had a resident psychologist that helped them. So I'm delighted today to introduce you to several people who are involved deeply in the amazing mission. And first is Matthew Shoup, who will give us an overview and a briefing on his own atmospheric science research. Matt, go ahead and share your screen. We're excited.
Very good. Well, thank you, Terry. And I will say right away, you said some real nice things about me, but I will say right away that there were so many people involved in this on so many different levels across the board. And it's really something that we should be proud of. And I'll get a little bit more back to that point in a minute. But yeah, thanks for the introduction and for the introduction for MOSAiC in general. This is my first slide here, and in my title, I talk about challenges and opportunities, and that's really kind of the message here. And we'll get into that in the next slides here a bit, but it really was a challenging year. But embedded in those challenges came so many different opportunities for great science, for personal growth for myself and others, and so many other things. So I hope in the coming time here, you'll get to see a little slice of that for MOSAiC. And so here, this picture is actually a great picture to show it. This is our ship, the Polar Stern, as it's frozen in the Arctic sea ice. And this is back in the middle of winter. And that's what winter looks like. It's dark everywhere except for the lights from the ship. So a really fantastic place. So I'm going to start though. I guess most of us on the call maybe haven't heard much about MOSAiC in the past or don't know many details. And I want to start a little bit just with some of the motivation. Why would we go to the Arctic for an expedition like this? And of course, the Arctic's changing. The sea ice is in decline. The temperature changes we're seeing in the Arctic are much faster than the rest of the globe. So there's all kinds of things happening to the Arctic. And our models that represent the global system, a climate system, actually do a pretty poor job in the Arctic. They don't really capture a lot of the changes that are happening there very well. There are all kinds of emerging operational and management needs in the Arctic. As the Arctic is opening, as the ice declines, we do resource development, cargo transportation, and so many other uses for the Arctic. And we really need to do a better job of kind of operating and managing those assets in the Arctic. There are all kinds of questions about the linkages to the rest of our globe. How does this changing Arctic affect our weather back home? And of course, there's a dearth of observations there. We just don't know all that much about the Arctic system relative to the rest of the globe. So these are some of the motivators for why we would want to go there. And just one more that's really hot off the presses is this figure from the NSIDC, where we look at, this is over time, the extent of sea ice. And as we all know, the ice It'll melt in the summer, it'll freeze up in the winter. And so it goes through this annual cycle of growth and decline. And the shaded colors on there kind of show where we would expect the ice to be. This is based on kind of long-term measurements. And then there's a few colored curves, and these are specific years that have happened. And those specific years, well, the red one's really important. That was 2012, and that's when we got to the record minimum sea ice extent at the end of the melt season. So in middle of September, the record minimum. There's also the green curve on there, which was from 2019, and the blue curve is from this year. So it's only a few days old, really. And we actually got to the second lowest sea ice extent ever recorded. So the Arctic is changing very much, and we're right in the middle of that change. And so these motivators, well, it got us thinking about an expedition. And, you know, I've actually been working on this for 12 years now. It's been a huge part of my life for a long time, working to build up a community of people that wanted to kind of join in this shared vision. And that's a huge international team of people. For designing this expedition, we thought this must be interdisciplinary. It must cut across the system, bringing together the atmosphere, the sea ice, the ocean, looking at the physics, looking at the chemistry, looking at the biology, all these different linkages in the system. And that's really important. And this expedition, more than any project I've been related with in the past, really does that. It creates these tremendous linkages that will really provide some foundational knowledge for us. It also has to be multi-scale. So we have the ship, we freeze that in the Arctic. And that's kind of a point measurement, if you will. But we also have a distributed network of measurements around that, providing some spatial context and variability. And then we also are very cognizant of the linkages between those kind of facilities and the rest of the Arctic in a kind of pan-Arctic sense. How do these measurements relate to other stations across the Arctic? So this multi-scale approach is really important. And then also we've had this integration of observations and models from the very beginning. Ultimately, our goal is to improve models, the models that represent our climate system, that forecast our weather. And we really need to improve those through this linkage between observations and models. The last key point about this expedition is the full annual cycle. We want to go there to understand the Arctic system in all seasons and how those seasons are interacting, because that's really important if you want to understand something like that sea ice that does change over the course of the year. So these were our thoughts for the expedition and what happened over the course of this year. Well, here's a nice map that shows where we went. We started out last September in northern Norway, took the ship out into the Arctic sea ice, rammed it in through the ice, kind of broke our way through and found a place to start there in early October. And then we drifted along this course. Each of these colors is a different leg in our expedition. And in between these legs, we would rotate people. Other ships would come out there and bring fuel and food and other supplies, and a new set of people, of course, scientists to look at different aspects of the system over the course of this year. Each of these legs had its own unique flavor. The first one, the installation period in red, we were setting up everything and started to drift and started to get familiar with this ice flow that we had found. The yellow one was the heart of the Arctic winter. The sun did not rise for these people when they were out there for many months. And then the green leg was a very long one. COVID helped to extend this because we couldn't get our resupply vessels in there. So some lucky individuals got to spend a couple extra months out there in the Arctic as the whole installation really drifted quickly across the Arctic due to this kind of large scale circulation pattern that was really blowing the ice across the Arctic. Leg 4, the blue one, was the melt season. I was fortunate enough to be there both on the first one and the fourth one. This melt season was very interesting, and the ice flow was way ahead of schedule in our drift, and we actually drifted all the way to the edge of the ice. And so the ship had to actually be reset for the 5th leg, going back up near the North Pole to finish out the year to look at the freeze onset. So moving from the summer melt back into the freeze up season. So this whole adventure across the central Arctic played out over the last year. So I'm going to go into a couple photos here just to kind of give you a flavor for this whole drift and how this all played out, and some of the challenges that we faced along the way. So this is just a nice picture of Polarstern heading out into the Arctic sea ice. Really beautiful picture in my perspective. This is when we're out looking for a floe to call home. And here was our first adventure onto that eventual home, onto the eventual MOSAiC ice floe. A group of us here, I'm in this group, we're heading out to look at how thick this ice floe was. And it turned out that the ice we found last fall was thinner than expected. And so we really had to make some compromises to go with a flow that wasn't quite what we had in mind, but we kind of had to do that. Then we started setting up some equipment. Here's a picture of some radiometers that are looking at the radiation balance at the surface. You can see the ship in the background there. Many other installations, buoys across the whole network around the ship to look at a variety of different components of the coupled Arctic system. Here's a nice picture from what we call Met City. So Met City was targeting meteorological measurements about 500 meters away from the ship to kind of stay away from the ship's perturbations. This is a nice picture after the sun has set and we're descending into winter. So this is the middle of the day, just for your reference. And at that point, we really started this very comprehensive set of physical measurements and sampling programs. So here's a nice picture of a person looking at some of the snow and snow depth, or taking ice cores, or walking across the ice to measure the ice thickness, the melt pond depth, the snow depth, all different properties to understand how the system varies in space and in time. Here's a great picture looking at the surface reflectance. This is a really important one for the Arctic. We need to understand what happens to sunlight. How much does it reflect back to space versus get absorbed by the surface? This is a really important component of this transitional Arctic right now. We're making measurements of the ocean. These people are profiling down into the ocean in the foreground, and in the background, there's a group of people flying unmanned aircraft. This is a CU project to look at the atmosphere. So both looking up above and down below, making all kinds of measurements. And one of the themes that kept coming up for us out there was ice dynamics. And by that, I mean ice moving and breaking. And I say here early and often, this is, again, another challenge that we didn't really expect to set in quite this way. Right from the beginning, these kind of cracks are going right through the middle of our camp. You can see the gangway. This is right off the side of the ship. Cracks breaking all over the place. And when those cracks break, well, eventually they come back together and form pressure ridges. Here's a ridge that totally ate up our power lines. So these kinds of dynamics happened all the time. Here's another great shot from above. You can see all kinds of ridges and leads around the ship. And one last shot, looking out towards our Met City. This was my home for much of the time. Off there in the distance, you can see our power lines are stretched across open water. The commute out to Met City at this time would be pretty difficult. We had to reinstall a lot of equipment, move things around, try to navigate out to these different research stations and try to keep these measurements alive in this really challenging environment. And it really was more challenging than we thought. I mean, of course, we knew the ice would break. That's part of the Arctic, but boy, it broke an awful lot, way more than at least I anticipated, and I think more than any of us did. But embedded there is this huge opportunity to really understand the emergent Arctic, right? This thin ice, this breakable ice, this is really part of the new Arctic, and we were right in the middle of it. Fortunate enough to capture a fantastic data set that will help us to understand the emerging Arctic. This is a great picture showing our ice flow from above. This is actually after I got back on leg 4. The ship actually had to leave the ice for a while because COVID made our logistics challenging, and the ship had to actually come out so we could rotate crew and get some of those people that had been trapped out there back home. We returned to our flow. This is the remnant part of it. Some of it had broken off, but this is the last bit of our flow. If you look carefully, there's some little bumps out on the ice. These are some of our installations out on the ice. And you can see these nice big melt ponds. The melt season was really setting in. And one of the cool things about this flow in particular is that it went all the way to the ice edge, right? The ice drift over this year was much faster than we thought. So again, another challenge, but it brought us all the way to the ice edge. And we sampled this flow until the very end of its life cycle, something we did not plan on. As we neared the ice edge, one day we made the decision to bring all of our equipment on board the ship. And the next morning, this flow had broken into 1,000 pieces. So it was really extraordinary to sample all the way to the very end and capture a very unique and unprecedented data set. So a few words about atmospheric science. This is my area of research, and actually a lot of the CU Boulder contribution to MOSAiC focused on a lot of the atmospheric components here at MOSAiC. So a few words about atmospheric science. One of the key things is that we packed tons of instrumentation on the ship itself. There are all kinds of installations I point to with the arrows, radars looking up at the atmosphere, air samplers to look at aerosols, to look at gases, so many different measurements right on the ship. And that's actually led to a lot of stability, right? We were not challenged to keep these instruments running because they were on a stable platform for the whole year. And we have these really remarkable and consistent data sets for the whole year. And I'll say that the sea ice has never seen such a comprehensive set of atmospheric measurements. This is a first of its kind ever, this extensive and comprehensive of a suite of instruments. Here's a great picture of one of our flux sleds in the middle of the night. And you can see the fantastic array of stars there. This flux sled, this is a sled that we can push around if we need to. But the point of it is to measure energy transfer at the surface. All the different components that would transfer heat between the atmosphere and the surface. So this includes radiation in the summertime, that's sunlight, emission from the atmosphere. This is turbulent mixing of heat. This is the conduction of heat through the sea ice between the atmosphere and the ocean. Every different term, we're there to measure all the terms and to understand their variability. What drives their variability? How does it change with season, when there's clouds versus no clouds, and many other drivers. And you can imagine if you're interested in the sea ice and why the sea ice might be melting or not, you'd want to understand all these energy transfer terms. So we were there, and this is one of our projects that we did out of CU Boulder. Here's a picture of the sled out over a melt pond. And this was on the last leg as the whole system was transitioning back towards freeze up. And the point of this installation was to monitor that energy transfer as the ice was starting to form. So we really did a fantastic job of capturing these key transitions in the system. One slide with some data. I figured that you all could handle a little bit of good data here. This is actually from a collaborator, Don Perovich, and this is showing temperature measurements that cut through the system. So I'll orient you here a little bit. On the bottom axis is year day. So negative values relative to the year days in 2020 would be at the end of 2019. And then you see the first handful of months of 2020. In the vertical part of the plot, at about 0 is the top of the sea ice. The positive values above are measurements in the atmosphere itself. And below 0 are measurements in the ice and the ocean. Initially, the ice was pretty thin, so we see a lot of ocean below here. I've labeled it. And then over the course of the year, the ice would grow, get thicker. And so you can kind of see approximately the ice base is this bottom black line. And we're just looking at temperature profiles. You can see the scale in degrees Celsius on the right. The point I want to make here is in the atmosphere, you see all these little stripes, these yellow and red and green colors here. These are basically warm air events. These are storms that come through. And what you see is their relationship between these storms and changes in the temperature within the ice itself. You get these warm atmosphere events that really drive to a warming of the sea ice and all these little subtle transitions over the course of the year. And then a really important one in mid-April, which I've highlighted with the arrow, where a very warm event came in and kicked the ice, made it really warm, and actually started its transition towards the summer melt season, which really started to set in over the last days in this plot. So if you want to understand the sea ice and its variability and how fast it grows or how fast it melts, you really do have to understand the transfer of heat from the atmosphere above. And that was one of the things we were doing with those sleds out there. So to summarize some of MOSAiC here, a little bit of by the numbers. Tremendous international cooperation here, 20 nations involved with more than 60 institutions, more than 400 field participants made it out to this ship out in the middle of the Arctic. We had 7 different icebreakers or ships involved, over $150 million total, over $40 million from US agencies involved. And those numbers are underestimates, I'd say, and are only growing in time. How about for Ceres, CU, NOAA? What was our role? Well, it was a really big role. We had so many different projects funded by DOE. We had the very first project funded there, a major atmospheric facility, and a few key science analysis projects. We have a number of NSF projects looking at, with those sleds I showed you, the surface energy budget, looking at gas transfer and ozone processes, flying unmanned aircrafts to look at the atmosphere, a big outreach and leadership project. You'll hear a little bit more about that. NOAA contributed a lot towards development of some of the instrumentation, including some of those flux sleds, and also providing some coupled model work. So this is a model that looks at the atmosphere, ice, ocean system together, and is really a foundation for advancing our knowledge by coupling our observations with this modeling framework. Around 20 people we sent to the field, and nearly 7 years FTE of person time in the field over this year. More than $8 million directly coming to the university, and more than $20 million supporting our projects in general, including things like paying for us to be on the ship, which cost about $600,000 a head for the year. So a real tremendous, huge investment of our time, but also huge success, I would say, in accomplishing all this science for our Boulder contingency. So to summarize, MOSAiC was this expedition that was characterized by challenges, but in those challenges were so many opportunities for really understanding the emerging Arctic. The ice was thin, it was dynamic, and we were right in the middle of it. And we did tons of science. We packed the science into the ship and all around the ice. There was broad participation from many international participants, different agencies within the US, and across different disciplines. We built tons of capacity out there. With all those people going to the field, we now have a new generation of trained field scientists that can really carry this research forward into the future. And we have new concepts for how to conduct research on thin ice. And I'll say our role, Ceres, CU, NOAA, Boulder, we played a huge role. It's a leadership role, and it's one that we should be really proud of out there. And finally, I just want to thank our funding agencies, NSF, DOE, NOAA, NASA, and also the Alfred Wegener Institute from Germany as the lead institution for MOSAiC. These all played a huge role in making this happen. And at the bottom here, we see a couple of web pages. Tons of great information there about the project, about the outreach, and the impact. So with that, I'll thank you and turn it back to Terry.
Thanks, Matt. I'm going to step in here. First of all, Matt, that was wonderful. And I think it's worth noting, I resonated with your comment in particular about a new generation of scientists for this sort of thing, because I know you got your start in a precursor investigation, this SHIBA, surface heat balance of the Arctic. Similar type of campaign, but not as sophisticated. We've learned a lot in the years. So thank you for sharing that. I'm Walid Abdullati. I'm the director of Ceres, and I couldn't be more proud of CU, Ceres, our scientists, Matt and others, for their involvement in this activity. I think it's been tremendous. It's a tremendous service to science. It's a tremendous service to society. I think agency missions are being fulfilled by virtue of the kind of work you've been done. And so many people have been involved. The 7-person years you referred to really is is quite tremendous, a big sacrifice. So thank you to you in particular, Matt, but all the people involved. And as I said, I'm director of CERES, Cooperative Institute for Research in Environmental Sciences. It's a partnership with NOAA, and you saw NOAA and CERES fingerprints all over this and what Matt had showed. And what I'd like to do, Matt gave us a bit of a tease on some of the science. There's going to be science coming from this for years to come. There's plenty to be learned. It's really literally a treasure trove of data. So I'm excited to see what comes. I do want to turn our attention to now, Matt had mentioned education and outreach, and I want to introduce Lynn Harden and Jonathan Griffith, who are part of the CERES Education and Outreach Program. They're funded through an NSF grant to engage teachers and students around the country. They've been extremely successful working with classrooms and students of all ages in all 50 states and in more than 120 countries around the world. And it isn't just students, you know, as you think of elementary kids, but it's really up through college, it's up to senior citizens. I cannot stress this enough, the importance of sharing the information, sharing the experience, getting people excited about the campaign, getting people excited about what's been done, and helping people understand the value to their lives, the value to our nation, the value to society, the value to science. So the education and outreach function is critical. It's a critical element in the overall success of the program and activity. So I am delighted to introduce Lynn and Jonathan to talk about the education and outreach activity. So I'll turn it over to you.
Thanks so much, Waleed. John is going to share his screen, but I'll start us off. So while he's getting that going, I just want to also mention that Anna Gold is the director of CERES Education and Outreach, and she's been really instrumental in directing the MOSAiC outreach efforts that John and I have been involved in as well. So I just wanted to acknowledge her. So I just want to start us off with a fun story that I want to share with you. So near the beginning of this year, just a few months after MOSAiC began, a middle school teacher in Albuquerque, New Mexico, sent us out of the blue a collection of movie posters that her students had created for the MOSAiC expedition. What was really fascinating about the posters is that they nearly all depicted the expedition as an epic Hollywood thriller, on par with The Martian or Gravity. Students drew scenes showing the polar stern icebreaker trapped in the ice with scientists frantically working, and posed dramatic questions like, what will they find and will they survive? Some students even went as far as casting actors like Chris Pratt and Dwayne "The Rock" Johnson in these movies. I personally can't wait to see A Voyage to the Center of the Arctic, starring Matt Shoup and Marcus Rex, Melinda Webster, and more. It turns out that in the 19th century, Arctic explorers were literally treated like movie stars and celebrities as they raced to see who could be the first to reach the North Pole and reveal to the world what truly lay at the end of the Earth. This is a picture of Fridtjof Nansen, a Norwegian explorer who is standing in a lifeboat of the Fram ship. And this was at the beginning of an expedition to the Arctic in 1893. The Fram ended up being the first ship to successfully become frozen in the Arctic sea ice and drift with the currents across the Arctic. You could think of it as the precursor to MOSAiC. Indeed, many of the Arctic explorers in the 19th century experiences read like epic tales filled with stories of bravado, adventure, triumph, and tragedy. This is a depiction of the USS Jeannette experience, which was not quite so successful as the Fram. The Jeannette happened before the Fram, and this ship was actually crushed by sea ice and sank, leaving the crew to abandon ship and continue on foot. One thing that we've seen throughout history is that people often unite around human endeavors that test our abilities, that push us beyond our limits physically, mentally, and intellectually, that involve great challenges to be overcome and that feel like they have a higher purpose that transcends our everyday lives. And more often than not, these endeavors have led to incredible advances in science, technology, and our understanding of the world. And these are just a couple more photos of the Fromm expedition that I mentioned earlier. So not only was this an expedition to try to reach the North Pole, but it was also an expedition to learn more about the Arctic and understand this environment. So this is all to say that as the MOSAiC Education and Outreach team, it was our job to try to figure out how to bring the MOSAiC expedition into the lives and minds of the public and into classrooms around the world. And we thought we could really capitalize around this phenomenon I just described. As educators, we also know that people are more likely to want to learn about and engage with something if they feel it's relevant and relatable, and if they feel like they're in some way a part of it. So basically our job is to figure out a way to make people feel connected to the MOSAiC expedition and to Earth's climate system. And as you'll see, we did this by not only highlighting the incredible science being done during MOSAiC, but also by shedding light on the human experience of MOSAiC team members and by trying to facilitate connections between the public and MOSAiC. So today, John and I are excited to share with you all the plethora of outreach resources we've helped develop over the past year to bring the expedition into the lives of people of all ages around the world. As you'll see, we tried to bring people as close to the Arctic and MOSAiC expedition as we could to really immerse them in the expedition experience and to make them feel like they were there. We're going to start with resources we've created for a more general public audience, sort of shown on the left side of this figure here, and then move along this spectrum to resources that we've created more for K-12 classroom use. Before we share with you some of our more specific outreach efforts and campaigns, I did want to mention that just like the MOSAiC expedition itself wouldn't have been possible without all of the collaboration and cooperation of hundreds of different people, not just the scientists, but the crew, the polar bear guards, the logistics folks, the filmmakers. We also wouldn't have been able to achieve the outreach success we have without the collaboration and participation of educators, scientists, media producers, and more. Collaboration truly is the key to reaching broad audiences. So those movie posters that I shared at the beginning of this presentation were part of this bigger campaign we had where we created a virtual online museum called the Museum of Mosaic Art, and we asked folks to submit their artwork inspired by Mosaic or the Arctic to be showcased in various galleries within this virtual museum. And so we just wanted to share some of the submissions that we got that we thought were pretty great. So this one is from Curtis, age 11, from Desert Ridge Middle School, who drew a picture of the polar stern in ice. This one is from Audie, age 7, from San Francisco, California, who submitted to us drawings of her favorite Arctic animals. This is from Eben, age 11, who drew a picture of a polar bear guard. And this one's from our very own Katie Human, a master potter who created this beautiful mug that is meant to show the interconnections between the Arctic Ocean atmosphere and ice. Another one of the campaigns that we did that was really fun to do was called Ask MOSAiC. So through this campaign, we asked the public to send us their questions they had about MOSAiC and the Arctic. We then relayed those questions to MOSAiC team members, many of whom were on the ship. We had email connection with folks on board the ship. And then we featured answers to their questions on our website and through some of our newsletters. And I just wanted to say that a lot of the questions we got ended up coming from kids, from students in classrooms. And what was really neat was the broad range of questions that we got. So it wasn't just questions about MOSAiC scientists, but kids also wanted to know things like, is the ship fancy? Or they wanted to know how the scientists were feeling and if they missed their friends and family, if it felt scary being out in the Arctic, or even just simple logistical questions like, how do you wash your clothes when you're stuck in the middle of the Arctic on a ship? So the Ask MOSAiC campaign was one way that we were able to directly connect the public with scientists and MOSAiC team members on board the ship. And we had another serendipitous opportunity to do this when the coronavirus hit. So when the coronavirus pandemic kind of blew up, And scientists on board the ship learned that they were going to be there potentially for months longer than they thought. We turned to the public and asked people to send us messages of encouragement to team members on board the Polar Stern that we then relayed to folks on board the ship. And we just wanted to share some of those really cool messages that we got that we were able to send along to MOSAiC crew and scientists. One of my favorites is the one on the top right here. You are the brave warriors of science. Keep going. Another of the outreach efforts that we were able to do that involved a really, really wonderfully large group of people and a lot of collaboration was a massive open online course, or MOOC, that we created about the MOSAiC expedition called Frozen in the Ice, Exploring the Arctic. This is a huge course available for free online on either Coursera or YouTube that involves over 45 lecture videos from more than 30 different MOSAiC team members, scientists, and just general Arctic experts. So if you want to learn more about the Arctic, the MOSAiC expedition, and just generally about Arctic geopolitics or indigenous peoples of the Arctic, you can tune into any of the 50 different videos available through this MOOC. Like I said, the videos are all available to watch for free on Coursera or on YouTube. And you can also pay a small fee to earn a Coursera certificate of completion or graduate credit through CU Boulder by completing this course.
Great, thanks, Lynn. I'm going to hop in here and say another tool that we used to try to connect the public to the expedition is through the development of virtual reality tools, virtual reality resources. And so many scientists, videographers, filmmakers had these 360 cameras and would bring back this amazing footage that we could stitch together and use to bring people to the Arctic, to tell the stories of the science and adventure. What you're seeing on the screen here is it's called a Google Expedition. It's an immersive tool. You can click and drag through these images, see what's going on in the Arctic at 360 degrees. These white icons here are points of interest that when you click on, images pop up and text tells you the story of that image, tells you the story of that scene. And we've got a number of different scenes, 8 different 360 images in this particular virtual reality tour that you can click through and see. We've also, I'm going to exit the screen here and take you to our website, where we have a series of virtual reality experiences. Some of them are like the Google Expedition you just saw on the screen. We've got a new Experience MOSAiC campaign in 360 degrees, where you can watch scientists play soccer or repair towers and click and drag as something that just came out on Monday, and I'll encourage you to check this out. A new 360 degree tour co-produced with some of our colleagues at Ohio State. What you're seeing here is the ice camp from the ship Polar Stern. And you have the ability again to click and drag in 360 degrees. Here's MOSAiC scientist from NOAA, Chris Cox, who captured these 360 images. And you're able to click on these blue icons and it'll actually take you to, here we are at Droneville. We can see the drone, the unmanned aircraft Matt referred to earlier. We've got MOSAiC scientist Gina Joseph over here. We can head to Met City. Matt's home for much of the expedition. You can see this tower. Oh, I got to click all the way around. This tower, we were referring to earlier, and these tubes capturing samples and bringing them to this shed here. And so lots of different ways to engage with the expedition, to immerse yourself in this amazing expedition. We often like to highlight new resources like these VR tours in perhaps our most popular resource, MOSAiC Monday. Lynn put together this every week, and it was a weekly update from the Arctic with different engagements. One of these engagements each week would be tracking the Polar Stern, tracking the ship. We'd provide the lat-long coordinates, and students would track and plot the course of the ship over the year. We'd also provide different observations, including temperatures, sea ice extent, among others. so students could keep track of these changes in the Arctic and ask really thoughtful and insightful questions. We recently reached out to teachers and students for some feedback and looking for some quotes and preparing for this. Most of the feedback was positive, but as a former 8th grade teacher myself, you're not going to get 100% positive from students. And something that was pretty comical to me, we had a student say, MOSAiC Monday, I love MOSAiC Monday. It's really fun. I learned a lot, but Monday morning, it's a little stressful to be doing this. So I thought that was pretty funny. The stress of having to plot a few points, a little bit too much for some of our 8th grade students. Classrooms that were really excited about MOSAiC were able to dive into 2 curricula that we developed, each about 8 to 10 lessons. In this particular curriculum, Exploring the New and Old Arctic, we really wanted to highlight the nature, the process of science, the adventure, as well as the science. And to do this, students compared and contrasted the 1893 Fromm expedition with the modern day MOSAiC expedition. And each activity was designed to help students answer this question: how have motivations, methods, technologies, and our knowledge of the Arctic changed over the past 125 years? And we use the VR tools that I just highlighted, and want to highlight one particular lesson in which we give students drift data from buoys, satellite imagery, as well as ice thickness maps, and challenge them to find locations in the Arctic that have ice flows suitable with attaching icebreakers to, very similar to what MOSAiC scientists had to do in the Arctic. Another unit that we developed, at the center of MOSAiC, trying to figure out how declining sea ice will impact some of these Arctic climate processes. And so we tried to bring that into this Earth systems curriculum. We present students with a visualization showing global temperature anomalies from 1880 to 2019 and highlight the fact that the Arctic is warming faster than the rest of the world. How is it that a frozen ocean could be warming faster than other parts of the world? And so through the engagement of these VR tools, authentic Arctic data sets, online simulations, among other tasks, students basically get to the story that an enhanced greenhouse effect caused by human activities coupled with a feedback loop, the ice albedo feedback, is one of the reasons, one of the mechanisms driving Arctic amplification, the warming in the Arctic. Over the summer, Lynn and I were really busy facilitating teacher workshops to try to get these units into classrooms. We had a lot of success, almost 200 teachers participating in various workshops and in analyzing the pre and post workshop surveys. Teachers' understanding of Earth's climate system improved significantly after participating in these workshops. Almost 100% of participants said they would take these curricula, at least parts of them, and facilitate them in their own classrooms. And so we're really excited about the reach MOSAiC resources, MOSAiC related curricula will have for years to come. For classrooms really excited and wanting to engage and connect with scientists and crew, we collaborated with an organization called Reach the World, where scientists and crew members, many of you on this call participated in this, wrote a brief article describing their work and then joined on classroom calls to present and answer questions from students. And it's an ongoing thing that we're continuing through November. We'd encourage you to explore our full array of resources from MOSAiC Monday, the curricula, these VR experiences. We've got a lot to offer, and we're excited to continue to increase our offerings in the years to come.
Thanks so much, John. And just to kind of wrap this up, so over the past 13 months, our outreach efforts have reached tens to hundreds of thousands of people around the world of all ages in all 50 US states and in over 120 countries around the world. And we've gotten really great feedback from teachers and students and just people generally interested in the expedition. And John's just going to give you a sense of what's next, and well, that'll be it for us.
Great. So yeah, we just wanted to highlight and kind of echo what Waleed said, and that is that while the fieldwork portion of MOSAiC is over, the science is just beginning. And Lynn and I are so excited to be a part of this team and so excited to continue and build on this momentum and connect the public with the expedition, the science, the adventure, And so, yeah, that's it for us.
Well, great. Thank you. And, you know, first and foremost, well, thank you for sharing that with us, but also thank you for making it accessible to so many people. Again, the value, the realization of the value depends on people understanding what's going on and the significance at all levels. So thank you both for your efforts. Next, I want to introduce Leanna Nixon. She is a CU Boulder graduate student in education. She's been on the Polar Stern for the last 4 months, sending us back amazing images and video of polar bears and seals, and even a few scientists. Talk about amazing images. And she's an extraordinary photographer and filmmaker, and will tell us what she's been up to on the ship. So Leanna, please take it away. Oh, can't hear you. She's in Germany, so maybe it takes a little while for the sound to get here. While she's doing this, I couldn't help but notice the men in suits on the Fram. It was kind of an interesting photograph.
Can you hear me now?
Yeah, we hear you now. Go ahead, take it away.
Oh, great. Sorry, I guess technology. Wally, sorry to cut you off there, but thank you so much for the kind words. As Waleed said, my name is Leanna, and I am a graduate student at CU Boulder, and I study education, in particular learning sciences and human development. And I literally just got off the Polar Stern. I finally got to eat fruit, and it was fantastic. So Katie, if you could do next slide, please. Awesome. So I just wanted to share a couple photos and stories that I have seen the past few months. I first of all just want to thank everybody for this opportunity, because I learned so much more beyond that I could ever imagine as a storyteller and as an educator. As a graduate student, in particular, I am very interested in how we use storytelling and virtual technologies such as 360 film to create a transformative educational framework about the natural world. So finding myself in this opportunity to film and co-produce a planetarium production has been really powerful. And Katie, next slide, please. And thinking about the planetarium production, we've already had 2 films that have come out. The first has been a 5-minute trailer from last year, and the second being a leg 1 update from Amy Richmond that really captures the dark season. And going back to what Matt Shoup said, a lot has happened since leg 1. We've had a lot of amazing and crazy logistical challenges. We've seen the melt season and been working under the midnight sun. We have packed up and unpacked flows twice or 3 times at least. And we even were able to return home as polar night would return. Next slide, please, Katie. So I wanted to kind of go over a couple goals that at least I in the field had while filming. And the first one is really capturing the insane amount of science that was being conducted on the flow and on board the Polar Stern. This here is the remote operated vehicle that the ICE team uses to look at ice surfaces below the water. And they're actually doing an optics dive in this. And we, with the 360 camera technologies, were able to take people into these very unique situations, such as being on the ROV, as well as maybe taking them up Matt's Met Tower, as we've seen in multiple visuals, but really showing the variety of science that's happening and the opportunities of multidisciplinary and interdisciplinary cross-cutting work that is happening. Katie, next slide, please. The second really big aspect that I thought was very powerful for in MOSAiC is what it takes to do the science on the flow in all of its successes and endeavors. It's the community of people who are there to help each other and support each other during times on the ice. This is Morven Molwick. He's an ocean scientist doing MSS profiling at 2 o'clock in the morning. You can't tell because it's midnight sun. But this was done during an intensive observational period campaign where everyone was helping each other, whether it was ensuring that equipment was okay, if needed help, as well as just also being a friend in the middle of the night when people were doing intense observations. Katie, next slide, please. And then just kind of as Waleed had said, I do send polar bear photos, but I'm hoping that the planetarium film captures what makes
getting in if I press
them and
So
why.
I'm sorry, Leanne, I'm going to interrupt here. If can I ask everybody to mute your line so that we can focus our attention on Leanna, thank you.
We good?
Yeah, go ahead. Sorry about that.
No worries. Okay, yes. Anyways, the Arctic is such a unique environment, and while many may see it as this very uniformed place, it actually isn't. It takes a lot of time to really look at it, investigate it, and see that it is actually pulsing with life, not just megafauna like polar bears, but tons and tons of microfauna. Next slide, please, Katie. And I'm hoping that the planetarium is also able to capture the fierceness and passion of scientists. I think the real passion that brings us out into the ice every day, that really drives us to continue asking the questions about such a unique place and continuing to return and nurture the science that we are conducting out there for centuries. It was a privilege to see the joy and passion for what they do out on the ice. And I think that their spark is a way that we can help inspire people to be more curious. And Katie, last slide. So overall, I have so much work to do ahead with 30 terabytes at least collected of footage on my end, much more from legs 1, 2, and 3. And it's very exciting to be co-creating a planetarium production that hopefully captures some of the feelings and ideas that I've shown in these photos. My greatest takeaway being on MOSAiC is that knowledge is one of the world's most powerful and transformative gifts, and its acquisition is only as successful as the community who nurtures it. So as we prepare to make a planetarium film that captures the MOSAiC story, the resilience of a dedicated community who has come together to pursue something beyond themselves and the Central Arctic, it's my hope that we continue to nurture the knowledge around the Arctic, inspire people to be curious about the world. So thank you. Thor is going to talk a little bit about the planetarium film that's currently at FISC.
So great. Thank you so much. And I see some pretty competitive series photography contest entries for the next.
Absolutely.
Thank you for doing that. So next, I'm going to introduce Thor Metzinger. Thor is production manager at FISC and an expert in virtual reality and other video techniques. And he's been the technical whiz behind the production of the Planetarium show. I can't, to feel the experience under the dome is really, you saw how beautiful Leanna's pictures were. Imagine under the dome in the planetarium, really, really powerful. So Thor, take it from here.
Thank you. Hello, everyone. I'm Thor Metzinger, video producer of educational programs here at FISC Planetarium. I'm going to try to keep this short so we have plenty of time for questions and answers. In the chat, I shared a YouTube link to our virtual reality experience from Amy Richmond's first film, From Leg 1 into the Polar Night. I'm going to just share that real quick so everyone can see that. So this is an immersive VR experience. So if you do have a headset, a VR headset, you can access this film on YouTube and look at it through the VR experience. We set this up in a VR FISC planetarium. and it allows us to still distribute this movie around the world, let people and planetarians watch the movie for free. At Fisk Planetarium, we believe in innovating immersive educational experiences to engage and inspire and build an inclusive community. And when Matt and Anna first approached me about MOSAiC and about this wacky idea of locking yourself into ice for a year, I knew we had to try to get this into the planetarium and try to make this an immersive experience. And VR is really, I'm going to jump forward here, VR really allows you to become one with the environment, and engaging an audience within a planetarium really, I think, connects to that visceral experience that we all want out of that photograph. You're no longer looking at a movie, you're inside the movie within the planetarium. So our first film has already been downloaded 54 times by theaters around the world in over 15 different countries. We were, expecting a big grand premiere within our theater, big reception, lots of fun, lots of laughter. But of course, COVID had different plans for the environment around the world and planetariums. So please feel free, look at this, experience the VR movie, even on your computer screen. The larger the screen, the better. So if you can access this on a really large television and still navigate the VR experience, you're gonna find VR shots that truly are completely unique in the world. And I think what makes all of the footage just amazing is that this is the first time any project has shot this much footage in VR in the Arctic Circle. I can think of no other production that even comes close. And I can't wait to see Liana's footage and see, what the story, where the story goes from here. And with that, I'll say, hopefully we'll have the theater up and running for public audiences, but this film and Liana's film are being distributed for free around the world. And so go to your local planetarium, and we hope to see you soon.
Great. Well, thank you, Thor, and thank you, everybody, for your presentations and bringing this to us. I'm excited on a scientific level. I'm excited on an education and outreach level, and I'm excited from just the striking visual imagery, both photographs, movies, and the VR experience. It's truly a tremendous offering, and I think everybody's really made the most of this opportunity. So thank you all. And now I'd like to invite people to ask questions. You can either type your questions into the chat, or you can briefly unmute yourself and ask your question. We got a lot of people, so the chat is probably a better avenue, but if you do want to speak up, go ahead. I just ask that if you unmute yourself, mute yourself after you're done asking the question, because too many microphones can be problematic. So fire away. And I'll let Katie manage the chat.
Well, I'm going to ask the first softball question then. Matt, you showed some pictures of leads, these openings in the ice. How did you navigate those to get between the ship and your research site?
Yeah, well, each day was its own adventure. And each time of year also is its own adventure. I know there's a number of people on the call here that had their own unique adventures. It was actually really fun to try to navigate, right? I mean, often there was open water or little ice chunks, or maybe it was just freezing over a little bit. And so sometimes you had to take bridges with you or build bridges. Occasionally there was, people would take kayaks across open water. And occasionally people would get wet a little bit. I admit to a wet leg at one time, just due to the challenges of getting out to our stations. And but in the end, that's really part of the adventure of it, and it really kept things fun and exciting. So each day was a little different.
Well, this is Jim Balog with the Extreme Ice Survey and INSTAR. And I just wanted to offer my congratulations to all of the incredible image makers and storytellers. Spectacular work. And I've seen it from the scientists here in that slideshow earlier on. It's beautiful, beautiful stuff. And I'm jealous I wasn't there because there were some good opportunities. But congrats to all of you for the great work that you did.
Yeah, thank you, Jim, for weighing in on that. Other questions?
We've got a couple of questions in the chat. Could you tell us about one of the most unexpected surprises on the scientific side?
Wow. I mean, a lot of that is evolving. I mean, certainly the ice was, I mean, we knew, of course, the ice is changing. That's the easy one. We know we're going into it. That's why we're going there, but it still surprised us with how breakable it was, how dynamic it was. So that was really interesting. Also in the summertime, of course, things melt and you get fresh water because of the snowfall melting. But this interaction between the fresh water and the salt water, even though I already knew about it ahead of time, it still was just so surprising at what role that plays. And it turns out, just like oil and water, right? Those water masses don't mix, and that affects the transfer of all kinds of things like heat, like gases. It affects the biology. And so to me, it was just really fascinating to see that play out and to be kind of surprised, even though at some level it totally made sense. And at some level we already knew about that, but we didn't really know all these details. So to me, there's so many things like that that are just kind of new aspects of the Arctic revealing itself.
We have a couple more great questions. Did anyone actually fall completely in the water?
Yeah, if you fell in the water at a certain place, you got your name, was embedded there. So it was, it's what, like Ian's Corner or something. I forget all the names, but yeah, if you fell in, your name would recognize that location. Although I'm sure there were many more that I myself got wet a few times, a number of other people, but fortunately when we're on the ice, we wear these suits that are flotation suits, survival suits, depending on the conditions, and people were always pretty safe even when they got a little bit wet.
We have a couple people asking a version of kind of how is all of this science going to come together and on what kind of timeline?
First off, I feel like I'm talking a lot, so we should have some questions for some other folks, but I'll answer this one as well. Scientifically, how is it all going to come together? Wow. So there's so many different people involved here, hundreds of people involved in doing the analysis. And so that's all going to start playing out now. We're all coming home. We're bringing our great data sets. We're bringing our samples to do analyses. And, I'd say it plays out in steps, right? Initially, we're all going to look at our own data, right? I was there to collect some measurements of my own, and I'm going to look at that and I'm going to figure out what's going on there. But the beauty of MOSAiC is this interdisciplinary component, right? There's so many different pieces coming together. And I'm actually interested in how my clouds or the radiation balance that I'm studying might affect some other person's aspect, right? How does that interact with the sea ice or the ocean, or does that affect the biology? These are some of the questions that really cut across the system. And that's the kind of science that will really start to set in maybe a year or so down the road, where we can start to understand our own data and then start to put the pieces together in this complex way. And then also to bring in models and bring in other perspectives that can help to synthesize that knowledge and really kind of advance it and take it up to the next level.
Another good science question. Sorry, Matt. The sea ice is more unstable due to which? Air temperatures or sea temperatures?
Wow. Well, I couldn't tell you a fractionation of those, but they're both important, right? I mean, the air temperatures, in the end, climate change is driven by greenhouse gases in the atmosphere, right? So it's an atmospheric phenomenon at its kind of core forcing of the Earth system. But in the Arctic, it's actually really interesting because you get that warming, it melts more ice, it exposes more ocean, which then absorbs more sunlight. This is called the ice albedo feedback, and it just amplifies itself. And so actually the atmospheric warming leads to a lot of ocean warming, which melts a lot of ice. And so these things are very much related. And it's something that, I mean, that's part of the reason we're there, is to understand the balance of these different energetic terms and how they come together to ultimately lead to all these big changes we're seeing.
Well, Matt catches his breath. I thought I would just point out two people really briefly. John Keller, who's the director of Fisk Planetarium, has joined us. There he is. And there are other scientists who are on various parts of the MOSAiC mission on this call. I see Dave Costa, if he wants to wave, and there may be a couple of others here. We do have another science question. Were the melt ponds really ponds on top of a deeper layer of ice, or were they holes of open water that connected to the ocean below?
That's a great question. And they're both, or can be both at least, right? Initially, they are melt ponds on top. You get the snow that's on top of the ice, and that will start to melt. It forms water, and eventually the water starts to differentiate into these ponds and little channels that connect the ponds. It's really a fantastic process to see play out. And then as that melting kind of continues, you get melting from the top and also some melting from the bottom. And eventually you start to get melt ponds that will melt all the way through, and they'll become very dark. And so that's a really important time for kind of drainage of all this fresh water through the ice and down into the ocean. And it kind of creates a Swiss cheese, if you will, out of the ice. And that's important from many different standpoints. So you get a little bit of both.
We could put Dave on the spot for this, or you, Matt. Were polar bears concentrated in some areas or more or less evenly distributed?
Let's hear from Dave, or Leanna has some great perspective on
Leanna, it's quite late in Germany and Leanna has gone to bed. I'm sorry. You stayed awake. Thank you.
Hey, go for it, Matt. You, yeah.
So the question was, were polar bears concentrated in some areas? Well, polar bears are looking for seals. That's, as far as I know, that's what they do. And so they're going to be concentrated in areas where there would be seals. And apparently, a couple months ago, that's where we were, because there were polar bears for 8 days straight. There were polar bears every day. And they'd come by, and fortunately, they would often come when we were already on the ship. That's the best time to come. One day, we happened to be making those measurements that Leanna referred to in the middle of the night. And that's when the polar bears showed up as well. But usually we kind of kept our distance and everybody was safe, fortunately, and we got some really fantastic shots. And Leanna especially, she had this amazing lens on a camera and could get right up there. Oh, truly fantastic. And so you saw one of those great photos, really an amazing opportunity.
I'm going to ask one more question here from the chat, and then maybe one person could unmute themselves and ask a final one. Matt, how do you feel after co-coordinating and completing such a massive expedition?
Well, mixed emotions, of course. I'm exhausted. All right, there's that part. Exhausted from many years of doing lots of hard work, but really inspired, actually. I mean, there's been so many tremendous experiences through this, learning about international coordination, working with such tremendous people from all over the world, realizing some of the skills of our own people here. I mean, I'm just amazed at the talents that we brought to the table from Boulder. Truly fantastic team that really did some amazing science. And so yeah, all these pieces coming together, and of course, the Arctic never disappoints. You know, I've been going there for a couple decades, and every time it just surprises you with how, yeah, mind-blowing it really is. All these different scenes. Maybe it's that polar bear with the little cub, or maybe it's some little formation of ice, or some brilliant day, some optics in the atmosphere. So many different scenes, and so it's done it again to me, right? This time it's done it again, and it's been really amazing to be there and to experience all those different scenes that it throws at us.
Is there any one more person who wants to unmute themselves and ask a final question out loud?
This is Terry. I will. I have a million more questions, but I don't want to keep everyone. I can't help but ask, this has just been phenomenal and just amazing to watch and to see what all of you have done. Was there ever a time that you really were truly scared to death up there? That you'll admit.
I don't recall a time like that, actually. There are challenges. There are times when your fingers are so cold that you're not sure you're ever going to feel them again, or, you know, I really wasn't scared though. I mean, bears maybe is the biggest fear, perhaps, but these bears were just being bears, and in the end, we did a great job of managing those. And so, yeah, I think there was no fear, just kind of excitement and adventure, and sprinkled in with a little exhaustion.
That's great. Well, I'm going to help close this here. I want to thank everyone who participated in the mission. Matt, for presenting today. I think the educational resources and the things that have been developed there are just phenomenal. It's just amazing what all has been brought together here. Not only the science, but really thinking about this in a holistic way of how do we share this with the world, and how do we make it accessible, not only kids, but even older kids like us. So I just want to thank the entire comprehensive team and everything that you've done. This has been so amazing. And I know there's a lot of resources here, and Katie, I assume you'll take the resources from the chat and send out to all those that registered. Is that possible? Okay, thank you for doing that. Because I think there's so many good resources here, and she'll send that out, so you'll get that. And not only is that there are things posted in the chat, but we want to make sure and get it right to you. So thank you all for joining us today. I want you to remember that this is the Research Week, which is what we're tying this into, the Research and Innovation Week. Feel free to visit www.colorado.rio, Research and Innovation Office, to learn more about the Research and Innovation Week events. There are more tomorrow and Friday, so don't miss out. And I want to thank everyone for joining us. This is a hard act to follow, I have to tell you. But thank you so much. And Matt, go take a nap. All right, thank you.
Yeah, thank you, everyone.
Thanks, everyone.